Hi, I am Christina. So for this problem, I am given a function and I am asked to algebraically find any zeros. Then I am asked to graph the function and compare the zeros from the graph with what I find during the first part of this problem. So I start with this function. I might actually try to separate it into two different binomials. I would break this apart. I set two sets of parentheses. I set a 3x, an x, and I would try to proceed and see if I could find two binomials that would indeed factor. I would attempt to factor this original function, but I would quickly see that that will not work. When that does not work, I then must use my quadratic equation, which I have written here. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. So these variables, a, b, and c, I can find those in my original function. My a will be the coefficient in front of the x squared. So in this case, my a equals 3. My b equals negative 12. My c equals 3. Great. So now I must plug in these variables into this quadratic equation, which I will do over here for us. So it becomes x equals, the opposite of negative 12 becomes a positive 12, plus or minus the square root of b squared. Negative 12 squared becomes a positive 144, minus 4 times a, which we've identified as 3, times c, which we've identified as 3 as well. That will be all over 2 multiplied by a, which becomes 6. Great, I can go ahead and simplify further. My numerator, again, I've got 12 plus or minus, and let's go ahead and see what we wind up with under this radical sign. 4 times 3 is 12, times another 3 is 36. I have 144 minus 36, which I might just plug into a calculator and get 108. So 12 plus or minus the square root of 108 over 6. Great. So now I ask myself, can I simplify the square root of 108? And that answer is yes. 108 can be broken down into the square root of 36 times the square root of 3. Oh, okay. Become x equals 12 plus or minus, and this would be the square root of 36 times the square root of 3, again, all over 6. Now I know that the square root of 36 is 6, so that could be rewritten as 12 plus or minus 6 root 3 all over the square root of 6. I go ahead and I simplify further. X equals, I'm going to go ahead and take my 12 divided by 6, which becomes 2, plus or minus 6 root 3 over 6. Here my 6's will cancel out. I wind up with 2 plus or minus root 3. So these are my zeros then. We've got 2 plus root 3 and 2 minus root 3. Now at this point I would actually even plug those into a calculator so that we have both answers, and that'll help us when we graph it and we want to compare what we found with what the graphing utility gives us. So I'll go ahead and my graphing utility, 2 plus the square root of 3, I wind up with approximately, do it down here, I wind up with approximately 3.73. And 2 minus the square root of 3 gives me 0.268. Great, so I have found the zeros algebraically. Now I'm asked to graph the function. I'll go ahead, I click y equals, and I can plot in the original function. I've got 3x squared minus 12x plus 3. I can go ahead and click graph, and I will see the graph magically appear for me. Now I'm asked to compare the zeros on my graphing utility with what I have found algebraically. Now to do this, we want to press second trace on our graphing utility. I will notice that there is an option that says 0. Now here you'll see that the graphing utility will prompt you to identify a left bound region. So you move your cursor to the left-hand side of what looks like the 0, and remember that the 0 is going to be where we are intersecting the x-axis. So I find a point there, I press enter. The graphing utility will then prompt me and say right bound. I move my cursor along just to the right-hand side of that 0. Press enter again, and it'll give me in the bottom corner that approximate 0. We notice that it gives me 0.267949919, which does fit our 0.268. We're going to repeat those steps to check our second 0. So I press again, second trace, move down to 0. This time I want to scroll over to the other part of my graph where I am crossing the x-axis. I press enter on a left-hand portion of that intersection. Again, on a right-hand portion, press enter a third time, and it'll tell me 0, x equals 3.7320508, which again matches with what we found here. So we have successfully found our zeros algebraically, graphed it, and confirmed our answer with our graphing utility. And that is how we do this problem.